In this video, we will look at the range, the set of all possible output values of a function, except we will relate the graph to the equation. In the first example, here, we have y equals the absolute value of x. Based on the graph, we can say that the range is y greater than or equal to 0. We can confirm this by plugging in values for x, the input, and finding the pattern in our output values. For example, if we plug in 3 into the absolute value of x, we will get 3. If I plug in -3 for x, I will get 3. Therefore, my output value of y will never be negative. And this matches our range of y greater than or equal to 0. In the second graph, we have the function 1 over x, y equals 1 over x. The graph appears to approach the x-axis, or the y-axis, but never actually reaches 0. Let's calculate this to confirm. If we evaluate for 1 over 0, our function is undefined for when x equals 0. We cannot have a 0 in the denominator. No 0 in denominator. This will result in our function being undefined. Now let's plug in and evaluate for when x equals 1/20. Plugging in 1/20 for x, we have y equals 1 times 20 over 1. We multiply by the reciprocal. Therefore, when our input value is very small and close to 0, our output value of y equals 20 and is larger. Now, let's solve for when y will equal 0. We can rewrite our function as follows. 1 over x equals 0. We want to solve for x. In this case, we can cross multiply, and our answer is x times 0 equals 1, which means 0 equals 1. This is not true. Therefore, 0, y will not equal 0. Therefore, our range is y not equal to 0.